All right, welcome everyone. Go ahead and share my desktop. All right, so content today. This talk is about some lessons I've learned dealing with Web API and putting some new services in production. My name, as was mentioned, is Ryan Riley. I work as a software developer for Logos Bible Software, mostly working on web platforms. I started in our commerce side with web forms and moved a lot of stuff to MVC. And we've recently been doing a lot of service extraction to provide additional services to our various mobile and desktop clients. Uh, we had some WCF services and then eventually moved to doing primarily MVC REST style services. And we've been looking at Web API for some time now. And we've been putting a few of those into production lately. So a lot of this talk is based on some firsthand experience with that. Um, in addition to working at Logos, I also work on a few open source projects, a few related to Web API, Web API Contrib, Web API Cones, which is currently only in F Sharp. I'm an F Sharp MVP, so I've been kind of focused on that side, but I plan to port that over to C Sharp as well. I help out with the F Sharp X project and a little web DSL called Frank that started off as kind of a Sinatra port and eventually kind of built on top of Web API. We'll get into that a little bit later, specifically because I originally was writing my own HTTP stack and found Web API to be an excellent stack, and so again, that's another part of why I think this talk and the services we've been building are actually a lot more fun and easy to do. So, brief history of Web API. There was a lot of requests for more of a first-class HTTP infrastructure. HTTP handler and HTTP module were really good for a long time. ASP.NET's been around for a while and has served developers really well in building some excellent web platforms. And then a few years ago, the REST Starter Kit popped up. It was part of WCF, and it had some success, but never made it as a full-fledged thing. And so people were still clamoring for more. There was some movement in the open source world, but then eventually Microsoft started getting involved through their WCF team and created WCF Web API. And I've been following this project since that time. As WCF Web API evolved more and more, it became more like MVC and then was finally adopted into ASP.NET. So I want to kind of cover a little bit of the actual stack itself, just a brief overview. There's some other talks on Web API, so I'm not going to go into too much detail here. But there's kind of three layers involved with Web API. That's top layer is really the Web API piece. It's the piece that comes in the MVC project, MVC4 project called Web API, and it involves all the filters, authorization, parameter binding, model binding, some additional formatter pieces in there, action filtering, selection, and all that stuff that's more or less familiar to those of you who've been using MVC for some time. The next stack is actually something that's built into .NET 4.5 and is also available on NuGet as system.net.http. I think it's actually Microsoft.net.http now. This is actually a very tight infrastructure that builds off of a very core piece called HTTP Message Handler and essentially builds up a stack. There's an HTTP server that's an instance of HTTP Message Handler that can be used as an in-memory host and is also the base for both the web host and self-host. And then you can stack additional message handlers. For those of you who've been using things in other languages like Ruby, Sinatra and Rack, or in Python with WSGI, you may be familiar with the term middleware. Message handlers can serve as a sort of middleware following the Russian doll model, which is pretty nice, pretty handy for things like logging and some other cross-cutting concerns. At the very bottom is the hosting. Again, HTTP server is the core for the hosting model. There's two servers or hosts available out of the box. One is for running on top of ASP.NET on IIS, and another uses the WCF HTTP transport along with the HTTP listener. And so those are out of the box. You can also use platform called Owen, Open Web Interface for .NET. There's some that lets you run other servers such as Kayak or Firefly and some other ones that are open sourced. If you want to do something like that, where you self-host on your own, it's similar to the out-of-the-box self-host, but they have a different memory management model and threading model. This diagram actually has been split up from Kiran Chawla's blog, and then the link is down here if you want to go check that out and look a little bit more at the stack itself. Okay, so the main part of this talk, because HTTP server can run in memory, it makes testing really easy. You can use HTTP client, which is another part of system.net.http, which gives you easy access to call into a web server and get back responses. It's also the thing that you would probably use in a consuming application on a desktop or mobile app. I think HTTP client's still being worked on for use in Metro apps. I don't know the current status of that, but I'm assuming that somebody will probably bring that up in one of the talks at ASP.conf. I haven't tried that yet, so I don't know what the details there are. So to give a kind of a brief overview of how this works, let's actually jump into Visual Studio and look at an example of this. And I'm just going to use the basic, I'm going to create a new project using just the default application that comes with the Web API project. So I'm going to use a new MVC4 application. We'll call it MVC application 2. Name isn't important. Pick the Web API template. The view engine is here. It doesn't really matter since you don't really use a view engine with the Web API. And we'll go ahead and create a test project as well. And I just want to look at the basic layout. There's actually, at least in my current installation here, I don't actually get all the things that I need, but we'll flesh that out in a second. First, I just want to look at kind of the basic layout of a Web API project, and then we'll kind of go into how you would test this thing. It's funny, I actually tested this project creation several times just to make sure it would be fast enough. I didn't want to cheat by having something in here beforehand, but this is the slowest I think this has run so far. Okay, so the default MVC Web API application creates two controllers, a home controller and a values controller. And notice values controller implements API controller. That's basically all the MVC type pipeline that does all the model binding and everything else for you. In app start, we're missing a few things, so we're going to add in a Web API config. And we're going to take in the HTTP configuration. This provides the various services and other routing and other aspects that are needed to run a Web API project. So if you've used this at all, you're probably familiar with these things. Create a route, and wants to use a default API route. Let's see, I think it's usually I think it starts with API controller, and we'll do some defaults here with ID, route parameter optional. Okay, so other things in the config could be additional formatters that you want to use, some filters, message handlers again that could serve as middleware. You can set some additional properties that would get passed into requests. Routes we're using here. Services include things like replacing the default action invoker, selector, value binders, API Explorer, which generates your documentation, assembly resolver. There's a number of different pieces in here that are that use the service locator pattern, and all these things are basically like known components. All of these things are replaceable just by using the replace. So if you want to include your own instance, it's very extensible. It's useful for testing. I'm not really going to get into that too much today because I'm going to be focusing on a slightly different approach for testing. Okay, so we've got our Web API config. Let's go hook that into our global ASACs. And we'll pass in the global configurations configuration property. And I'm going to get rid of this apt start in the namespace. Okay, so this should now be routed. We should be able to hit values at, so this is my startup project, just to verify that this works. Open in Vim, which is my favorite text editor. And there we go. We got our JSON value, JSON response of value 1, value 2. Now, a much better way of testing this is to use Fiddler, which I have open here. So let's see what happens if I pass in a different accept header. And we can get back XML instead. Okay, that's all basic Web API stuff. If you've been following along with Web API, you know all this stuff. Not very exciting. All right, well, let's look at see what the default test project shows or gives us. All right, so we have some test methods for the controller. We're actually just calling, let's see, we're creating an instance of the controller, invoking a method and verifying some results. Most of these tests you'll notice are empty because, for one, most of the implementations are empty. But two, most of these things, while this method looks very familiar to an MVC developer, this isn't really all that useful. I've got a post that's taking a value and returning void. Well, that's not really what we're doing here. We're really doing something more. And what we're really doing, if we go to the top, I'm going to add a method to test our values in a slightly different way. And as I write this, you'll see a bit more of what we're actually trying to get out of this. All right, so if we're going to test the Web API using HTTP server and HTTP client we were just talking about, this will give us a really good integration level of what's happening in this service. So we'll start by creating a new config. We'll configure that thing using our standard configuration. Now we'll create a server to run in memory, passing in our configuration, and we'll consume that server with HTTP client. Okay, so what we've done here is we've created an in-memory host for our Web API, and we're also created a client to consume that service or that server. Notice that the client actually takes an HTTP message handler, so this could actually be almost anything. It could be one of your middleware pieces. You can test a whole lot of stuff through this HTTP client. You don't have to create an entire server with a full configuration. So keep that in mind as you're developing your apps. In a lot of cases, if you just want to test that a middleware type message handler works, you can easily just pass that directly to the client, make some calls, and verify that the behavior is correct without having to set up an entire service stack. Okay, so that's our setup. Let's invoke our get, and we'll pass in our URL. We'll just call it, for testing purposes, we can make up pretty much anything here. And I'll show you that's the case here. The main part is passing in the correct endpoint. This is the part that's matched by our configurations routing. So this is the part that actually matters. If we get that wrong, then we'll see some problems. Okay, well, this is actually going to return me a task of a response. And well, we really just want the response. In .NET 4.5 and Visual Studio 2012, you can actually use the async tests and not have to call a result. I've tried doing testing with .result to immediately get to basically block and wait on a result, and I've also tried using continue with, and I've had kind of mixed results with both. So your mileage may vary there. I've kind of started leaning on doing .result in my tests. This is pretty dangerous if you're running in ASP.NET for web hosting, so you generally want to use continue with, or if you're using .NET 4.5, the async await pattern within C#. Anyway, we got a response back, and now we want to do some tests. So let's say assert r equal HB status code OK is the same as the response.status code. All right, let's run this test, see what we get. And yes, I realize that the title of this is test first, and I'm doing test last, but we'll get to the test first piece in just a minute. Okay, so let's go back to look at the controller, and then we'll look at this test again. Controller, get, takes nothing, returns an enumerable string. Our test passes in a URL and gets back an HTTP response message. There's something of a discrepancy here. Now what I have tested is I've tested that the routing works. I've verified that I've gotten a response back. I've verified that I've got the status code OK. None of that is available in this. Now, there's some assumptions, there's some conventions that if I don't pass anything, I'm getting back at 200 OK. But how do I do something where, say in post, I want to send back a different status code? Well, the easy way to do a post would be to say, do some addition to my repository and return the new value. You'll likely want to do a status code if created and a location header with the URL for the new value. Well, following the normal MVC approach of doing, well, I guess this isn't truly MVC because MVC would have action result. So it's nice that we can actually return back just real values. Unfortunately, this string value isn't really all that helpful because what I really need to do is return back a bunch of other things about that value. So when you're building these things, you'll start noticing a pattern here. You're going to end up seeing that you a lot of times need to return a response message. In fact, almost all the time. The only times I've found that you don't need a response message are generally when you're doing gets. Puts and deletes, and sometimes, a lot of times I'll return no content. There's different trains of thought there, but for almost anything other than get, most of the time you'll end up finding that you need to do something more. So what I've started doing is I've just always returned an HTTP response message. Web API helps a lot with this by having an extension to do create response. And then you can set your status code and set the value. Still don't have our location header here, but this gets a little bit closer to what I actually wanted. And right now I'm just doing a little bit of exploratory piece here, but let's see what happens when we actually want to implement this thing. All right, so we'll go back to our test and we'll add a test for doing this post method. I'm going to actually just change this one. Since we already have a test for get right here, I want to change this test to do a post. Let's see, and this takes a request, need an HTTP content, oh, formatter, that's what I'm missing. There's some built-in properties for some of the default formatters, so this post async will get me on API values, I'll post value 3 as JSON. So what I want to do here is make sure I get a created response. Let's see if this works. And it does, because I already set that up. Okay. Now, let's add a location header. I'll just end this last piece. We'll test the absolute path. And we'll manually set this for now. We'll look a little later at some of the URL helpers and things like that that can be useful. So run this again. Next, let me make sure this actually builds, because right now it won't. Okay. So now I'll add my location header. And I'm just making this piece up. Again, most of the time I would use a URL helper, but for this test I just want to stick it in here and see if I get the value out correctly. Okay, so I'll rerun my test. And we got a pass. Okay. Not really impressive. The main point being, again, I really need an HTTP response message for most of these things. And honestly, even for the gets, it's not really that difficult to do. A few more keystrokes, a little bit more noise, but my controller is actually starting to show me a little bit more correctly what I'm actually doing here. I'm taking it, well, I don't really get the request in here, but I am sending back a response message, and that's really what's important, at least to me. Okay. So let's go back to the slides. So what are we actually testing? Well, there's a couple things that we're doing here. We actually are testing routing, authentication and authorization, other HTTP configuration settings, action selection, results, use of message handlers, because if we have anything in the pipeline, we're getting some of that. We're also verifying HTTP response message details, content formatting. There's a whole lot of stuff happening in here. What happens if I go back and decide, you know what, I really want my routes, I don't really like this API prefix. I just want to do this. Okay, make that change. Run my test, and whoops. Oh, that was a different issue than I was expecting. Oh, right. Let me go undo that. Okay. Okay, now because my route is wrong, my test fails. So granted, I probably should go and change my tests first. But a lot of times you make some of these changes and you think, oh, that's not a big deal. I'll just make that change, and then all of a sudden everything starts breaking. Okay, what about if we want to add some authorization? Well, let me verify that this actually is still running first. Test should pass. Cool. Go back. I don't want just anyone getting in here, so I'm going to add the authorized header. This is using forms auth, which is the default. You can do a lot more stuff with the ThinkTexture packages that they have for security. But in this case, I just want to show how easy it is to break these tests. So now you see that we went from a working created, it said not found when I changed the route, now it's unauthorized. How do I get around this one? Well, this one really bit me for a while because I wanted to test my authorization, but I really didn't have a good way of doing so. So I put a debug and other stuff in here to conditionally modify that. It's sort of annoying. What I really want to do is focus on writing my tests, and a lot of these pieces are just kind of in the way most of the time. When I really want to focus writing my API, I've got all these other concerns. These are important concerns, granted, but there's a couple of other, like when you're writing your APIs, you want to make sure that you're actually able to make sure that those things are working without having a bunch of other stuff in the way, preventing you from making progress. So the goal is to focus your tests. The base that I found useful is, again, this request to response type of function. If you notice, the API controller, the simplest, this is kind of an opinion of simplest, but the simplest API method you can write is an HTTP GET request to an HTTP response message. Sorry, HTTP request message to HTTP response message. This is a synchronous method, and it's really just a function. You could pass this in using the method name pattern and basically create a func delegate out of it. But this gives you all the pieces coming in from a request and all the things coming out of a response. It's about as simple as you can get when you get down to what's really necessary for making these things work. The HTTP message handler signature has a protected method, send async, that is almost the exact same thing, a request to a task of response, and also takes a cancellation token. So really, what I like to focus on is making sure that I got my request to response pieces working correctly. Now you're probably asking, why just this one function? We were looking at an example that had things that really didn't need anything from the request, that were returning some data, some that took a few pieces like an ID from the request, or an ID and the message body from the request. Why is it necessary to focus on the request and response? Well, that's really what you're working on here. If you think about it, you should be testing your domain already. If we go back and look at Visual Studio, if we're testing get, now granted, this is somewhat contrived because there is no domain in this case, but consider that this is actually hitting a repository and returning some data. If I test this method, it takes nothing, it returns a non-enumerable string. This get method is really just wrapping some domain layer something. That's not really of any value. I should have already tested this, which means that I really don't even need to test my APIs at all, which is certainly not the case. If I test this method the way that this default test method works, I'm getting absolutely nothing of great value here. Again, the test we did up here, where we're testing the entire infrastructure, is pretty useful, but starting off, there's so many different variables, especially as you're potentially beginning to build this API. You don't know the routes, you don't know some of the different pieces or status codes you want to use in a certain way. There's enough churn and change that you're likely going to just keep bashing your head against things you don't realize and having your test break as you make minor changes here and there. So the goal is to make sure that your requests and responses, again, the core part of this service boundary here, this HTTP piece that bridges the gap between your domain and any clients using it. This is based on HTTP requests and responses, and that's really what we want to test. We want to make sure those things are working correctly. We want to test that service boundary. We want to test HTTP itself. Is this really useful? Okay, this is where experience comes in. There have been several times when I've been trying to write my APIs that, well, the authorize and the API removal on the routing were actually two real instances that I ran into. They seem really simple and they seem really stupid, but I ended up spending quite a bit of time trying to figure out exactly why my tests were failing, because I was going through making what I thought were pretty simple changes. You definitely need to eventually hit the integration piece, and those pieces, again, are very important. But a quick rundown of the pros and cons of the differences is probably helpful. If you're using API controller the way that the default shows it, the pros are your GET requests can be really, really simple. In fact, they're almost always delegators to some domain method that you already have. The main difference is sometimes you have a URI parameter or a query string parameter. The URI bound variable parameters are actually really important because otherwise routing doesn't work. If you take off an ID that's needed in a route pattern, that action method won't actually even be found. So you do have to leave it in there. But most of the time, those signatures are pretty light. I haven't found that I often have a lot of things in my action methods that aren't something from the request body itself. Another benefit of having the action selector type where you have parameters in the action method and a concrete non-HTTP response message return type is that other developers who come to your API in the implementation can determine a little bit better without reading the internals of the method what it's trying to do. Again, if it's mostly gets, that becomes a lot easier. But as soon as you start hitting posts, you're going to almost end up returning HTTP response message anyway. And so it's not really, I don't know how much of a pro that is. If you're not focused on, or if you're not worried about correct HTTP status codes or various headers, then it's probably a good point. Having the normal action method signature is probably a little bit easier to follow. Then again, most of the time if I'm reading through some code, I'm not going to just look at type signatures on the method level to give me the detail of what that thing is trying to do. Most of the time the name is more helpful, or even some pieces of the implementation are better. So again, your mileage may vary there, but that's been more of my experience. It can alleviate a line or code or two, or even just some characters, so it can be a little bit more terse when you use the more MVC style action method signatures, but the biggest one probably being you don't have to read the request body manually, but that's again like one line of code and not very difficult to do. The cons. In order to get anything other than a GET, URI parameters are often only supported for routing. So trying to remember what I meant by that. I don't remember. My notes are not as thorough as I'd hoped. Anyway, one of the things that I have seen some other people run into, we usually know that the request property is available in an API controller because the same is available in an MVC controller, but it's not immediately visible, and so sometimes that can be a little bit of a surprise. The same thing with some of these other helpers, like the URL helper. Some people will end up making their own thing without realizing that something is there. That's a read the manual sort of thing or documentation sort of thing, but it can happen. Reading the request body from request.content gives more control and is sometimes required anyway, especially in the case of something like multi-part or streaming You'll end up having to read it manually. You can't use the method parameter from body, um, and you're forced to do it on your own. It hides the fact, and this is again more of a personal thing that I've run into. The use of the MVC style approach hides the fact that you're really dealing with a request response interaction. Um, Again, it's more because when I'm testing, if I don't think about the fact that it's a request and response, I'm often going to forget to test those things. Even when I'm getting a response back, um, if I'm initially writing the method and trying to verify that it's working, I'm going to be testing and thinking about what I'm actually trying to do without the different pieces that need to go in there. So returning back the body of a request. So if I create a new value, in the case earlier, I should be returning back a created status code and location header. But if I'm just thinking about I'm getting a string or returning a string, I often tend to miss those little details that are important for HTTP interactions. And again, finally, a con of using the like the string to string type of approach is that you almost always need to return an HTTP response message anyway. The extension method on request.createResponse is extremely helpful and makes this not much of an issue. So I recommend trying to always use it. So my typical approach to this is to build with functions. Functions are really easy to test. They can easily be composed, so you can write little ones that wrap up into other ones. They also generally help you avoid shared mutable state, which is usually the biggest reason for bugs. So using functions allows you to kind of avoid that stuff. You can also use closures to wrap things that would normally be handled by IOC if you have a top-level static implementation of something. That sometimes helps. It kind of depends on how you build your apps, but it's just an approach that I like. These are all things that can be learned from doing functional programming, and C# does allow a pretty good way of doing this. All right, so the contact manager example from the Web API team is a pretty familiar example. I want to go through and show how we could take this approach on the post method in the contact manager. So I'll collapse this sample application. We'll go look at our contact manager. The contacts controller has several methods. A get for everything, a get for a single ID, and a post method. You'll notice here that this one actually can return either a created response or a bad request response. So in this case, we're definitely going to be returning back an HTTP response message. This controller also has a put and a delete. These just return contacts, so you can assume that this is returning a status code of 200. Again, important to remember to test that and verify that, so that it's in the future if something changes or if you decide you want something else, you'll want to make sure that you are able to identify those changes. All right, so our goal here is to rewrite this post method using a test first, function first approach. If you look in the existing tests, the post method is using the same pattern we had earlier, where we have a configuration, we configure it, use a server and a client to get it. We post a value as JSON, and we verify that the result is not null. And then this one also includes a test to verify that the location header, it both exists and is a valid location header. All right, so I'm going to create new post functional test. And I hear some static in the background. Somebody's mic. Okay, so what are we testing for? What we really want to know is we want to get back a response from some method. We'll call it, we'll go ahead and use this instance, and One of the things here we can look at, or I can show, is you don't always have to have like a static class to hold your functions. You can actually put these directly on your controller type. So what we'll do is we'll create a controller. So here's my new context controller. I need to pass it a repository. So we use a sample there. All right, and we want to do a post, let's call it post function, and we're going to pass it a request. So we'll also need a request. This takes a HTTP method, so we'll use a post, and it also needs a request URI, so we'll give it our localhost. I think this is just contacts. Let's verify that. In our web API config. Nope, it uses an API prefix. Okay, so we need to put that in here. Actually, in this case, it really doesn't matter. We'll just leave it as this just to prove the point. All right, so routing isn't being tested here. We can verify that. All right, now I need a post function. And this needs to return an HTTP response message. And our first test is going to be that the response is a created response. Okay, and this is going to fail, which is fine. So we expect it's not implemented. So we'll implement it. Okay, so now we return a message or response that's just created. Should pass our test. Cool. All right, now we next want to assert that the contact data that we send matches the contact data we get back. So this is not tested above, but we are going to verify. Let's actually just test that it's not null first. We do get back a contact. So we'll need to we want a result, and that should be response dot content. Read as async contact. I'm just going to pull this contact test that they have above down here. Okay, we can't say contact is equal to result. Well, for one thing, we're not testing that yet. This would be handy. Unfortunately, because these are going through serialization, we're not able to actually test these, so we'll have to actually test the properties explicitly. Since we're only testing one, that should be sufficient. Okay, so let's run this. This is going to fail again. Because we're not actually returning something, so it should fail on the first one, which is a null exception, so that worked. So here, now this is where things get fun. On request, what we're going to do is we're going to read the content. And then we're going to continue. So the signature of this is now changing. All right, so you notice we went from a synchronous test, request to response, which could be useful for a GET, to a task-based one, because we need to read the content out of the request. So async await would make this a lot nicer. Unfortunately, I don't have that on here, so we're using the continue with to get there, and then we return back our response after the result is in here. All right, so now we should get back. That's to modify our post function to get the response by calling result. So this should actually pass now. Oh, but it doesn't. And that's because we are not passing in a message body. So create a new object content of type contact, passing in the contact, and we'll use the JSON media type formatter. So now that should pass something in, and we run this. Right. So you notice there's a little bit more detail in going through here, but you get a better sense of what actually is happening throughout the process. So here we have to actually specify this JSON media type formatter. But as we're going, I can also verify what's happening, that things are getting selected properly, that I'm getting the results back that I want. If I really want to, I can also, instead of verifying that the names are correct, I could actually, without reading as async, I could read this as a string and verify that the output of my JSON serialization is the stuff that I want, without having to go into a browser and navigating to the API and trying to see it that way. Okay, now this isn't all that exciting. You're probably thinking this looks like a lot worse than what I had before, and you're actually correct. So this is really more of a starting point. Again, this is the goal here was to make sure that I didn't miss some things that I wanted in my HTTP. So now that I've got some of that, I can start working back towards this approach. I can tie in my configuration. I can tie in the pieces that let me use the URL helper. One big problem with the approach I'm taking right here is that I can't access this URL helper because it's not set. I also can't set the request property because that's not set either. So there's definitely limitations to doing this, but again, for my purposes here, I wanted to make sure that the core part of what I was trying to do was actually working, and I've verified that. So now what I can do is I can start evolving my test back, adding in the configuration, verifying that the server and the client are all set up correctly. But I've already verified that the test works, that the method works. I can now pull this post function back up towards this piece, get model state validation, things like that. And that's how I've been working with my my tests and building up my controllers. Again, verifying that the core functionality is working, and then going back and adding in the extra pieces that I need in order to get access to things like the URL helper. In this case, get route data, also not set when you're not going through the entire stack. It's not that these things aren't important. It's just that it's more difficult to verify. It's harder, at least for me, with all the distractions, to make sure that I'm verifying the things I really want to make sure I'm using. So I call that process reintegration. One of the main things is that the only way to get access to your HTTP configuration is through HTTP server, because it's the lowest level message handler that actually takes a configuration You can create a static one that's accessed or just a variable that's accessed from other places. You can actually pass in an HTTP configuration in these methods where we are passing in formatters, such as here. Oops. Create response will actually take an HTTP configuration as opposed to just a formatter, so it can actually do the content negotiation for you. All right. So that's just scratching the surface. Some things that I've been looking into beyond this level. This really just kind of got me started into thinking about what else could I do with taking a function-first approach. Daryl Miller has written a really cool message handler called API Router. This is one of his many contributions to the Web API project. It's an open source project, API Router on GitHub. It uses an HTTP message handler to do routing. The goal that he had on this was to give full control over routing resources, so you could do nested resources and verify that it's more of a declarative approach to defining where everything exists. So we'll take a look at that. And this is kind of moving back to message handlers as more of a middleware, but this is also replacing the default configuration routing and leveraging a full-scale assault into the system.net.http pipeline. You can think of this as really just functions for routing purposes. The best example of this is his GitHub API router, which is available as a sample within his project. So this GitHub API router maps to a root controller and then starts adding in additional routes to various other controllers as you go. And he's essentially recreated the entire GitHub routing mechanism through this. Again, this is an HTTP handler, which is essentially a function from a request to response. And so this thing's actually doing the mapping to the various controllers at various levels. He's even got ways of differentiating additional pieces. So like start and public are actions or filters within a gist controller. It really is kind of taking control over the pieces, like being able to get route data, being able to test without having to have a full HTTP configuration and server and client stack in the way. Using this, you could avoid some of those pieces and pull back. As an example, as exemplified in these tests, you can get the URL for a controller or for a route, which gives you back the actual URL template that you can use as a means of actually pulling the user ID and repo ID in this case out of that piece. It further makes the MVC style actions less necessary. If you're not familiar with it, system.service model includes a type called URI template that will take something like this and an actual URL and pull and map out the pieces, like these bound variables, user ID and repo ID, into a collection that you can then go and access. All right, so API Router moves further in that direction. The thing that I've been trying to look into more is going functions all the way. It's more of a thought experiment and just trying to see what you can do, but could you build an API using only message handlers? Could you build an API with only functions? This being taking the core of what a message handler or a controller action is supposed to be, making that a function, and then building out the entire thing to be hosted within Web API without actually using any of those pieces directly, and then eventually in the end wrapping them back up within a message handler, a single message handler, or something like API router in order to host that thing. And being an F# MVP, I started doing this with Frank. F# has first-class function support, being a functional language. The results of what I build in Frank get wrapped back up into an HTTP message handler. And this still barely scratches the surface of what I think is possible. For instance, I don't have the same type of thing as what Daryl has created with API Router. in Frank yet. I've been working on building something similar. Darrow has the advantage of using a lot of the pieces that are kind of built for Web API, using the MVC stack, the API controller, a lot of the routing mechanisms. Whereas trying to stick with just message handlers gets a little bit more tricky. But I think I'm getting some pretty good results with it. So as a quick demonstration, this is a Frank application. It's intended to, again, this is F#, so I apologize if the syntax looks a little unfamiliar. This is modeled after the same contact manager application we were just looking at. And here I've got a module for models. I've got my contact and a little database I wrote using an actor or a mailbox processor from the F# core libraries. It has certain methods: get all, get, post, update, delete. These are kind of like my domain. This is really kind of my domain, if you will. The contact manager app is pretty simple and straightforward in terms of what its domain does, and so this is just a little wrapper that does the same thing. In this case, I'm actually going to be using closures to access the data. So I create an instance of my contacts repository, fill it with some data, and there's some implementations of the formatters that are used in the contact manager. Some of this isn't quite fleshed out all the way, but what I'm going to do is kind of break all this stuff up into different modules. So I had my data module, my resources module, and as opposed to being everything in different files, this is all in the same place. So I can see everything very easily, but it's still broken apart quite clearly with the different module deviations or barriers. So in this case, what I've been able to do is I created a function called respond that returns a new HTTP response message and uses function composition to create the response. So it takes a status code, it takes a content type, and I'm basically composing this piece together with these various functions. In this case, this is a function that returns a header and adds it into the response that's generated. This header's content type is text HTML. And then I've got another function that formats a string. In this case, it's basically just creating a string content with an encoding of UTF-8 and a media type of text HTML. And this will actually return back a hello world page that looks exactly like this HTML looks. And then an echo function that takes a request returns an async response message. In this case, this is very similar to what I would normally do if I was writing an echo handler. Uses a task in here. It's copying the stream over, copying the headers, and returning it back. The cool piece here is that I'm actually doing routing with another function, and then my method. So each of these is actually an application on its own. They both take requests and return responses. This hello resource routes the combination of hello world and echo mounted at two different methods under a given URL. So in this case, I'm going to route and create a resource at the root path that returns at get this hello world HTML page, and then if you post to it, it just echoes back whatever was posted to it. And then I created a contacts resource. This one ends up getting mounted at /contacts. And here I've got two functions. One is all, which runs a content negotiation algorithm. This is different than the built-in one. I could easily have just done request.createResponse and returned the values here. But in this case, I'm using a different content negotiation algorithm, passing in some formatters and getting all the data and returning that. And this will go through and format all my pieces. It's really just function replacement. Again, I could have used request.createResponse. Here I can use run coneg. In the end, it doesn't really matter. It's all functions, so it just composes together nicely. Create takes a request message and returns a response again. I read out the form data from the request body, create a contact off of that. I'm using dynamics here to set my model values. I post that data into my database asynchronously. So if I have a big load of things and this takes a long time, which in this case it doesn't since it's in memory, but if it were, it could continue working even as it's trying to post data. And then coming back, I'm using a different content negotiation piece from negotiating the media type directly and then returning back some content based on what I found there. Again, returning with a created status code. I'm not sending any headers back in this case. I'm returning the content that's been formatted with the selected media type and the formatter. And if I can't negotiate that correctly, I'm going to return a 406 not acceptable. So again, this is like essentially breaking down into content negotiation manually and doing the dirty work myself. But again, there's little functions here that are all composed up and are all actually run within this run coneg. This one's just done this way in order to kind of show the build up. And again, finally, it's a get on all and post on create, all mounted at /contacts. The cool thing with this is that they're all simple functions. They're all easily testable on their own. I could easily just take this all and mount it directly on here, and any method running against all would return the same thing as if I did the get here. Then I have a contact resource. This is getting probably old and familiar at this point, but this just gets a single one, returns back a response message again, and then mounted at /contact/ID. In this case, I'm using URI template here. And this URI template, again, as I mentioned earlier, can pull out the bound variables and query parameters when there's a match found. So the pattern looks the same as what you're used to in routing, and fairly straightforward and simple. I can pull out the same types of values that I'm getting out of action selector, but doing it myself, having a little bit more control, using smaller functions that I can easily compose together in simple and new ways. And then finally, if I have multiple resources, I can merge those together into a single app. Again, this app is a request to a async, in this case, since it's F# response message. I can pipe in some middlewares. For me, this looks a lot more simple. I can see everything a lot more clearly than having a separated config where I'm passing in message handlers and things like that. But in the end, both are really doing the same thing. But you can, in fact, get to pure functions at the result here. And then I have this extension method, register. And this is just an extension on the configuration. Register takes an app, which is a request, an async response message. It does a simple route addition and then adds an async handler that takes my app. So in this case, it's actually all functions running, all composed functions that are all running together. And the only part where I actually start touching system.net.http in the larger sense is, or web API in the larger sense, is actually right here where I'm adding in this route and this message handler. Everything else is easily tested with a function, and I don't need to worry about any kind of infrastructure or configuration to get there. All right, so in summary, we covered some basic testing in Web API, looking at the infrastructural kind of default way of doing things by creating an in-memory server and connecting to that with an HTTP client, sending some values, getting some responses, and talking a little bit more about how there's so many things tested in there that it can often help you or kind of be a distraction and make you lose focus on what you actually need to test. We looked at a few ways to remove some of those distractions by starting with a pure functional approach, and then reintegrating those kind of initial efforts back into the standard approach of building tests and building web APIs. We also looked at a few deeper ideas with API router and Frank, and kind of as a kind of a summary note on this, is this approach for everyone? Possibly not. I've definitely found that it's been a great help to me, making sure that I'm actually testing the things that I need to test. If you're a lot better at handling a whole bunch of different things flying at you at one time, you're probably fine without having to worry about all those extra efforts and steps of creating separate functions and testing those independently. Certainly, no project is the same. I would recommend if you're writing an API that's mostly Gits, that you don't even worry about this. For the most part, you're probably going to be writing um, delegating wrappers around your domain, or in some cases, your domain may just be um, pushed right into your web API because it's just not that important. Um, However, if you're doing a lot of posts, puts, some other HTTP methods, you're going to find that you're going to end up using a lot of request and response properties, and that's where a lot of this starts coming into play and becoming very useful and handy. So I encourage you to at least try it. Think about the different aspects of HTTP you're using, and with that, I'll open it up for any questions. Thank you for those of you who attended, and are there any questions? Okay. Um, One thing that I've been asked in the past when I brought up some of these ideas is related to performance. And so far, I've never experienced anything related to performance issues. I've never tested it to see if this is slightly more performant or slightly less. Um, I do know that because of the use of type descriptors and the things that are used in MVC and Web API at the top level add a little bit more dynamic use, but they're also usually pretty fast. So I don't know that there's any real trade-off or benefit to either approach, but that might be something to consider or look into more for those of you who are interested in that. All right. Well, thank you, everybody. In case the link is still not there, my speaker rate URL is right here. I noticed that the link earlier wasn't on the website, so if you wouldn't mind, I'd appreciate any feedback you have. And again, thanks again for attending, and I hope you enjoy the rest of the conference.